Hello guys, this is Paul McWhorter from TopTechBoy.com, and we are here today with lesson number 29 in our improved, our most excellent Arduino tutorials. And what we're going to learn today in lesson number 29 is we're going to learn a little bit more about using a push button switch as an input device on your projects. We learned the basics of operation for a push button switch in lesson number 27, where we could turn an LED on that as long as the button was held down, the LED was on. When the button was let up, the LED went off. This was pretty simple. But in that lesson, we learned the concept of how to use pull up and pull down resistors with a switch. Then in lesson number 28, we went a little further to make a little more interesting switch, a toggle switch, where if you press the button and release, the LED would come on. Press the button and release again and the LED would go off. Very similar hardware and circuit, but we had to think a little bit more about the coding and the programming. Today we will take it to the next level, and what your assignment today is, I will need you to build a circuit with two push buttons and an LED. That is, you press one of the push buttons, either holding it continuously or pressing it repeatedly. The LED will very gently get brighter and brighter and brighter. And then if you press repeatedly or press and hold the other LED, the other button, the LED will gradually get dimmer. So one button will gradually bring up the brightness, the other button will gradually bring down the brightness of the LED. So I will need you to pour yourself a most excellent cup of iced coffee. I will need you to get out your Lego Super Starter Kit. If you don't have one, check out the description. Click on the link. $35, you get a boatload of components, and this is the kit that I use for all of the lessons in this series. And so if you get that, you'll have identical hardware to me, and if we're working on the same hardware, it will be a little bit easier for you to follow along with me. Okay, let's get started on this project, and I will get out of your way, and then we will switch over to our overhead view. And what I need you to get out for this project is you will need the Arduino Uno. You will need two push button switches out of your kit. You will need two 10K pull-up resistors. You will need a red LED. Remember, we saved the green and the blue LEDs for special occasions. Not going to use them today. We're going to use the red one. Need a 330 ohm current limiting resistor. You will need your buzzer, and you will need your breadboard. Okay, so here's how the assignment's going to go. You're going to go away. You're going to hook the circuit up, and then you're going to write your code, and you're going to make it work, and then you're going to post a comment down below in the comments saying, hey, I did it by myself without watching what you did. Or you're going to say, hey, I just really got stuck and I had to watch what you did. Or you're going to say, I did it by myself, but I did it a different way than what you did. And so let's get some discussion going down there, because there's a lot of different ways to do this, and I will show you one. Go away and do it yourself, then come back and do it with me or watch me. Okay, go away, pause the video, then come back. Okay, did you get it working? Did you get it working? All right, well, I'll go through it with you. And I'm just going to remind you to use a switch. You've got to have a pull-up resistor that connects to one pin of the switch, and then you've got to take that connection and go out to a digital pin on the Arduino, and you will read from that pin. Okay, you need to have the other leg of the switch hooked up to ground. And then the LED, of course, you know how to hook that up. 330 ohm current limiting resistor in series with the LED, with the long leg of the LED always pointing back towards the voltage source. In this picture, I'm using pin 12 as the read pin from the switch, and pin 8 for the LED. And then remember, you're going to need to build two of these. Also, remember that if you look at your switch, there's pins that are sort of pointing towards each other, curved towards each other. Those pins that are curved towards each other need to go in a common column. So those two pins that sort of curve towards each other go to a common column, and then the switching occurs between these pins which are not going to be in a common column, and so that's where your switching is going to occur. That's where your switching is going to occur. Hopefully you understand that. If you don't know what I'm talking about, go back and watch lesson number 27. I can't slow down at this point. All right, so we're going to start by building our switch, and you can see here that those pins are the ones that are curved towards each other, and so I'm going to put those in a common column. I'm going to start like over here. Okay, now I will need, did that go in? Yeah, I believe that went in. Okay, now I am going to need my pull-up resistor as such. Okay, and I'm going to go ahead and get this one going too, so where the pins are pointing towards each other, I will have those pins in a common column if possible. These are kind of hard to plug in. The little switches are always kind of hard to get in a breadboard, but I will say the ones with the eLego kit work better than a lot that I have tried to do. All right, now I'm going to put my pull-up resistor, again, same column as one of the legs of the switch. Sometimes these things are hard to get in there, and this particular resistor doesn't want to go in. Okay, so now do you see that I have two switches and I have two pull-up resistors? Now I need to go to 5 volts. What is my problem? My problem is my Arduino only has one 5-volt pin coming out. So what I'm going to do, I'm going to connect to that 5 volts, and I'm going to bring that down here to row number 2, which is the positive row, and I'm creating the positive row, the row that's marked positive, and now I've created a rail so that all of these holes in row 2 have 5 volts. So now all I got to do is just grab off of that 5 volts. These things do not want to plug in today. Sometimes when you have a new breadboard, they're kind of tight to begin with. Okay, there I am in. So now I'm connected to 5 volts from the second row, and now I'm connecting that to my pull-up resistor. I will need to do a very similar thing over here with the second pull-up resistor. That second pull-up resistor will be connected to 5 volts as well. Now those two switches will need to be connected to ground, so I will take the bottom leg of the switch and I'm going to connect it to G and D by the 5 volts. And I don't have to create a ground rail because I do have 3 grounds and that's how many I need. And if I don't have to create a ground rail, I don't. All right, now I will come and take that switch to ground. So now I pretty much have that built, but remember, I do need to read off. So I've got this much hooked up, but now I need to read off that node that connects the resistor to the switch. I need to take that. I'm going to take the first one to pin 12. So right there, right, that connection between the switch and the resistor, I will take to pin 12, and I will be reading from pin 12. And then on the second one, the second switch, similarly, I will take that node that connects the switch to the resistor. Let me get this where you can see it a little better. Okay, that node that connects the switch to the resistor, and I will take that to pin 11. So on pin 11, I will be reading from the second switch. I have my grounds, I have my read pins, I have my 5 volts, so that one's all done. Now what we need to do is we need to, you know what? I am going to need a ground rail because I forgot about the buzzer. So, change of plans. I am going to take my ground wires out. I'm going to come from 1 GND on the Arduino, and I'm going to come to row 1. Right? I'm going to come to row 1 on the breadboard. And that row 1, now that entire row 1 is going to be ground. So now all I got to do is just connect to row 1, and I will be grounded. Connect that to row 1. My second switch to row 1, it's grounded. And then my first switch to row 1, my first switch to row 1, and it's grounded. So I do indeed believe that I have this all hooked up now, the two switches with the pull-up resistors. Now we need to go to the LEDs. So we will start with our current limiting resistor. I'll go from like column 25 to column 30. And then long leg of the LED into the lower leg of the resistor. And then I need to ground the LED. So then the short leg will go to row number 1 up here. Remember, row 1 is my ground rail, so now that's connected. And now I simply need to come over to the top leg of the current limiting resistor. That's the left leg. And then I think that I will bring that to pin 3. Now, since we are going to be controlling the brightness of the LED, we will need to use one of the digital pins that has a squiggly by it. That would be 3, 5, 6, or 9 as far as the ones that we still have available. And I chose to use 3. Okay, so that is looking good. And now we still need to put our buzzer. I am using the active buzzer in the eLego kit. That is the one that has the black on the bottom. Remember that these matter. It matters on these buzzers as far as the polarity. And so I've got to make sure that I'm connecting the positive, and I am running out of wires. Can you believe that? Okay, I'm going to connect the positive pin. And this is just going to be an on or an off, so I'll just use any old digital pin. So I'll say pin 2. And then I need to ground the other side of this. So I will come here to the other leg of the buzzer, and I will take it to my ground rail, like that. Okay, that looks pretty darn good. I hope that you could follow that. Guys, you should be able to do this because I have done all of these in earlier videos, and if you're taking these in order, you should sort of know what I'm talking about, and I can't just take an hour to fully explain every single step on every one of these videos. Otherwise, they would get very long and very boring, and I'm already getting people complaining that they are too long and too boring. So let's start coding this thing, and because this is a little bit more of a little bit more complicated, let's see. I think we will go to this view, and that looks pretty good. I might make this a little bit wider. Let's see how that looks. Give me a second to get this all straight. Okay, that I think looks pretty good. All right, so first thing I want to do is I want to work over here on these buttons and just see if we can get these buttons working. So how do I need to do that? Well, I've got to set up some pins. I've got 2 read pins, and so I'm going to have int, and I'm going to have button 1. I'll say button pin 1. And you can see that as you start getting more complicated in these things, you need to start kind of being really descriptive on what your variables are. So button pin 1, that one I believe was hooked to pin 12, so we'll say that that's 12. That looks good. Then int button pin 2, and that was connected to what? That was connected to 11. All right. And now let's go ahead and do our pin modes. And so we'll come down to void setup, and I will say pin mode button pin 1 is a what? It's an input. We're going to be reading from that. And then pin mode button pin 2. Similarly, that's an input. Happy little blue color because it recognizes the word. That's always good. Recognizes pin mode. Now when we come down here, I just want to read the two values. So I'm going to say, if I'm going to read them, I better have some variables for that. So I'm going to have int, and it's going to be button val 1, no value in it because it's going to read it, and then int button val 2. So now in my void loop, I will read those two values, and so it is going to be button val 1 is equal to digital read. And what am I going to read button val 1 off of? Button pin 1. Does that make sense? So now I've got a value for, is the first button up or down? If it's just sitting there up, it should read a 1. If I press the button, it should read a 0. So now I'm going to go button val 2 is equal to a digital read of button pin 2. So I'm just trying to get my buttons working before I write a whole bunch of big long thing of code. So let's just get the buttons working. Let me come over here to this. So now let's see what we're gonna get. I'm going to print this out, and I'm going to give a series of prints. If I'm going to print, I better put my serial begin up here in the void setup. Serial.begin, trusty old 9600. Now I should be able to print. And I'm going to do kind of a string of prints here. So I'm going to say serial dot print ln. And what do I want to print? I'm going to print button button 1 equals, like that. And then I'm going to and that should be serial print because I want to string these things across. So then let me copy that so I can kind of start going a little faster. Control V. And then what I'm going to do is serial print, and then I want to print what I read. What did I read? I read button val 1. Then I think that we would sort of repeat this. I hope I've got an undo. Now let me just build this. Let me kind of keep building it. Now I'm going to do a serial.print, and I'm going to put a comma to get my formatting nice. Okay, now I'm going to do the same thing on the same line for button val 2, but I can Control C and Control V those two, and then it's going to say button 2 is equal to button val 2. Okay, did you guys follow that? Button val 2. All right, so then this should print out what state these two buttons are in. And so let's just go ahead and download that and see if this is looking, sorry. Let's see if this is looking good. Hold your breath. Oh, what's wrong with button val 1? What is that? Button pin 1. I said button val 1 and button val 1. Were you guys yelling at me? Button val 1, button val 2. All right, download. What is not happy here? Serial. Oh man, I am a horrible speller. And then to make it worse, I copied and pasted. We have to spell serial correctly. Serial. Sometimes I make mistakes on purpose, and sometimes I'm just not paying attention. Okay, those look good, and this one I misspelled as well. Cereal. Okay, now they're all the happy little orange color. So let's look at that. Okay, boom. Boom. So let's see. Okay, so here is, I'll show you the code here. I'll show you the serial monitor. Okay, do you see what the problem is? I never put a serial print line over here, so it's just going across. So I really need to put a print ln at the end, so it will go to the next line. And also, it's going much too fast, so I need to put a delay of dt is delay time, and then I need to go up and define delay time. So I will come up here and I will say int dt delay time equals, let's say, 250 to slow this down some so that we can see it. Let's try to download that again. Okay, and I'm going to try to make this bigger. Okay, and I think you can see that, and I do need to get out of your way a little bit. So this, we can see that something is wrong because it's saying button 1 is equal to 1, what we would expect, and button 2 is equal to 0, which is not what we should expect. And so I might have a problem on the circuit, because right in the up position, it should not, in the up position. Oh, look at this craziness. Look at this craziness. What did I do on the circuit? Were you guys yelling at me? Were you screaming at me? What did I do on the circuit? I never came over. Oh, wait a minute. Wait a minute. Yes, I did. Okay. So that does go to pin 11. And I say button pin 2 is pin 11. So that looks good. Button val 1 is digital read, button pin 1, button val. Ooh, what should this have been right here? Oh, you can't see me. Okay, I'll come back over here. Okay, I found my mistake. You see, I said button val 1 is digital read, button pin 1, and button val 1 again. That should have been what? Button val 2. All right, so now let me come back to a good view here, and let me download it again and see if that will fix it. Okay, boom. Do you see how I'm getting button 1 is a 1 and button 2 is a 1, and that's what you would expect. Now I'm going to press button 1. What would I expect? I would expect button 1 to go to 0. Boom, look at that. And then I let it up, and then I press it, and then I let it up, and then I press it. Okay, now button 2, let's see if it works. When I press button 2, what should happen? It should go to 0, comes back, goes to 0. Boom! Okay, do you see how much easier my life is going to be now? Because what do I know? I know my 2 buttons are working, and I know that I have a button val 1 and I have a button val 2, and button val 1 tells me is button 1 being pressed, button val 2 tells me is button 2 being pressed. Most excellent. So now I'm getting good data. Now I just have to figure out what to do with those values. And so I want to control the brightness of the LED. So I probably need what? I probably need a new variable up here that we are going to call int LED bright. And I'll just start it at 0 so that it would start in kind of the off position. Okay, it would start, put in a 0 there. It would start in the off position. Now I'm going to come down here, and the first thing that I will do is I will just go ahead and at the very bottom, I will do a analog write. And what do I want to analog write? LED LED bright, like that. So LED bright is 0. And so after I go through the loop, the last thing that I'm going to do in the loop is apply the desired brightness to the LED. But what I got to figure out is if button 1 is pressed, I want to do what? If button 1 is pressed, what do I want to do? I want to make the LED brighter. So I'm going to say if button val 1, and put my parentheses around there, parentheses. If button val 1 equal what? 0. That means that button 1 is being pressed. What do I want to do? I'm going to say, well, bright, I forget what I call that. LED bright. LED bright. Is that how I did it? Yeah. Is that how I did it up here? Yeah. Okay. LED bright is equal to, let's say LED bright plus 5. And so if the button is down, it's going to kick up the brightness a little bit. All right. But what have I got to think about? I don't want to, I think I will deal with that later. Okay. So if the button 1 is pressed, I'm going to kick up brightness a little bit. And then how about this? If button val 2 equal 0, what does that mean? Well, that means that button number 2 has been pressed, and in that case, what do I want to do? In that case, I want to say LED bright is equal to LED bright minus 5, right? I want it to get a little dimmer. And then what it will do is it will then write that to the LED, and hence it will be changing the brightness. Now let me see, did I do my pen mode? Oh, I didn't do my pen mode on the LED. So I need to make sure that I do that. Pen mode, and I don't even have an LED pen, so I need to do that too. So I need to put int LED pen, and we're going to set that to 3 because it was connected to pin 3 in the circuit. So now I have an LED pen. Now I've got to do a pen mode on LED pen, and that is going to be an output. All right, so you see I was coding up the buttons, and then I forgot to do some of the stuff that I needed to do on the LED. And similarly, we're going to have to go back later, and we're going to have to put some work in on the buzzer. But for right now, we have the LED connected, and so here we go, here we go. All right, now what else do I want to do though is I've got to be really careful because I don't want to write something that is greater than 255, and I don't want to write something that is less than 0. So I'm going to say if LED bright is greater than 255, what do I do if LED bright is greater than 255? Well, I'm going to say LED bright equal to 55. So if you're just sitting on that button and you got it above 255, it's going to come back and it's going to put a ceiling at 255. So you're not going to be able to go above 255. And then similarly, if you're sitting on button 2 and LED bright is less than 0, what do you want to do there? Well, you want to say LED bright equals 0. And so what this makes sure is these two if statements make sure that you never try to apply a signal greater than 255 to the LED, and you never try to apply a signal less than 0. All right. This is going to be kind of interesting to me because I think that it might work. All right, so let's download it here. Oh, LED bright. What is wrong with LED bright equals 0? It doesn't need a close parentheses there. That was quite foolish, right? Quite foolish. Let's try again. And analog right, LED bright. So now let's make sure this parenthesis goes, or that curly bracket goes with that one. 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 The void loop ends there. You see, I'm just making sure that all of my I'm making sure that all of my curly brackets line up. So it doesn't like my analog right. Why does it not like analog right? I've got to give it a value, so I'm going to analog right. I got to tell it what I'm going to analog right to, LED pin. And did I do that right? LED pin. Yeah, so I'm going to write to LED pin. What am I going to write? LED bright. Now, when I download this time, it is going to be happy. Okay, it's going to be happy. And look, the numbers are coming up good. Both of them are up. Both buttons are up. And so now I'm going to try to give a little brightness by hitting button 1. Look at that. Did you see it came on just a little bit? Do you see it's getting brighter as I either hold it? Boom! This thing is getting brighter and brighter and brighter. Okay, all the way to full brightness. Okay, half of it is working, but now can we bring it back down with button 2? Okay, it is coming down, it is coming down, it is getting dimmer and dimmer and dimmer, and it is off. Okay, so I can control the brightness with these 2 buttons. Okay, what is the one thing I still need to do? Like if I just sit on this brighter button, I need to give an audible feedback to the person like, hey buddy, stop hitting the up button, you're all the way up. So where would be the best place to do that? The best place to do that would be if LED brightness is greater than 255, issue a warning. And so we are going to need to turn pin 2 on because pin 2 is what the buzzer is hooked to. So now I will say int buzz pin is equal to pin 2. And then I'll have to do a what on buzz pin? I'll have to do a pin mode, and then we have buzz pin, and what do we have? It is an output, all right? And then what do I do here? If I hit this thing too hard, I need to give a warning. So now I'm going to say digital right buzz pin, what? High? Now, let's give it like a half a second. So then what I will say is delay by what? DT for delay time. And I need to come up and set that variable up if I have not. Yeah, delay time I already have, but I'm going to put it at half a second. Let's say 500. Okay. So if I've hit that button too many times and it's already maxed out, I'm going to turn the buzzer on. I'll leave it on for delay time, and then I will digital write buzz pin what? LOW. All right, so if you turn the buzzer on, you got to remember to turn it off. And then similarly, this same thing we will want to copy. And then down here, if we're hitting the down button too long, we can give the person a warning. Hey, buddy, take your finger off the button. So now let's see if that will work. All right. Now when we do this, it's going to reset the brightness to 0. All right. So now, okay, it's starting to come up. I can see it coming on. coming up. Getting nervous here, getting nervous here. I'm not hearing the buzzer come on. Okay, so the buzzer didn't work. Let's see, I am on pin 2. I am grounded. I am connected upright. So the good thing about these things is when they happen, first thing is it seems like the circuit is working. One thing is I can test the buzzer. I'm just going to come in and I'm going to go to row 2, which is my plus 5 volts. So you can see, hopefully you could hear that. It's kind of an annoying noise here. Hopefully what you could see there is that the buzzer is working. So for some reason I am not turning pin 2 on. So I say if LED bright is less than 0, then I say LED bright is equal to 0, and digital write buzz pin high, delay, and then digital write buzz pin low. And then if I look at buzz pin, it is pin 2. So this is getting quite mysterious why it does not seem to be. All right, so what am I going to do? Am I really getting in this loop or not? If LED bright is less than 0, am I really getting in here? So I'm going to say serial.println, and then I am going to just type in buzz high. And if I see buzz high, I will know that I got into, or this would be buzz low. And that's just basically saying that I'm in that if statement where the value was too low. And then I will take this and I will also put it up here as such. And if I'm end up here, that is saying that I should buzz because it's too high. So since it's not buzzing, I'm going to see, am I at least getting inside of these two if statements? All right, so I download it. Looks happy. All right, it's reading both buttons is up. And then as I hold this down, you see I don't ever appear to be getting to, you see I never see it printing. It is never getting in there. So it's like LED brightness never gets above 255. All right, then what do I do now? I need to print LED brightness because I think that I'm holding it in long enough to be that bright. So here, I'm just going to do serial.println. I'll take all these out later, but it helps me debug. LED bright. So I will see what the value is, okay? I did not make this mistake on perfect, but I am going to figure out what's wrong. Okay, so you see LED brightness is 0 if you look here, coming off the serial monitor, and then I hit it and it goes to 5. The LED does come on. Okay, 10. All right, so you see we're letting it get brighter and brighter and brighter. Do you think I just didn't hold it on long enough? It should go to 255. I bet I didn't hold it on long enough, and that's why it never issued the warning. Ah, okay. Yeah, you know what? It was working all along. I just wasn't patient enough, and it was kind of, you know, going sort of slow. I'm going to leave this on here so that I can see it, but if I'm at full brightness and I try to go brighter, you see what it does? It gives me a warning. Okay, so now let's dim it. Okay, so you see it's dimming. And do you notice how I can hit the button repeatedly, or I can just press and hold? We're down to 170. You're visually able to see the LED getting dimmer. 65, 55, we're getting there. Okay, and we get the warning that you can't go any lower. The LED is off. Okay, I really like that. The one thing, like what you might do is you might play around with, I think a way to improve this would be to play around with these offset values, and maybe the -5 and +5 for each button push. Maybe what I would do is maybe it should be +10 and it's a little bit more responsive, but you could play around with that and see what you like. Boom, guys, this was a great project. Look, we're starting to get more complicated in what we're doing. Look at this. We have got two input buttons. We've got an LED, and we have feedback through an audible feedback through the buzzer. And so if you look at this, you've got two input devices, which are buttons, and you've got two output devices. One output device is the LED. The other output device is the buzzer. I think this is a pretty cool project, and actually I kind of had some fun playing around with this. I hope you enjoyed it as well. Okay, guys, this has been kind of 3 lessons on the buttons. You can see they were probably half an hour each, so I didn't want to make an hour-and-a-half video, but between these 3, you've got kind of like now a new tool in your tool set, and that's how to use buttons to give input to the Arduino and kind of control what is happening. All right, guys, this is Paul McWhorter from TopTechBoy.com. I will talk to you guys later.